All right, guys, so here we go. For Lab 15, this is called Where Did 0dB Go? And this is a gain structure discussion. This is one, really, I put together, the genesis of this was a long time ago, and it was really about when we were making the transition from analog to digital and the different metering styles and the different, it wasn't necessarily different gain structure, but it was what, because the different metering, that we were having on the digital consoles, it was really throwing people off. So I decided to put together a whole thing about this. So this is where we're going to go with this. And always remember, certainly in my labs here, with few exceptions, this will always be geared toward mixing music, right? The things that we want to have in play when we're mixing music. Okay, so just keep that in mind. All right, so any gain structure discussion at the console level, for my money, kind of starts with this discussion here. And it has to do with dealing with fader resolution. And, a lot of guys confuse this with audio resolution. We're not talking about audio resolution here. We're only talking about fader resolution. How can I move the fader with the most, the highest degree of detail in it? And we work in this, these audio logarithmic scales on these faders. And it can be, it's not linear. That's the thing to remind you about here is that, the same distance move at the bottom part of the throw versus at the top part of the throw creates a very, very different change in decibels with the fader, right? So if you notice here up at the top one there, a move of that distance is a 5 dB change, right? Where if we move down in the bottom of the throw half that amount of distance, it can be a plus or minus 20 dB change, in that same distance, right? So the point to get across here is that we want to work as mixers, especially as music mixers, with that fader up in its high resolution area where we can make very fine adjustments. The PA systems, everything have enough resolution in them now that we should be able to hear very small adjustments in fader movements. And you want to be able to do that delicately and purposely up in those areas. Now, the question always comes up, well, what's the range where you think it's still in high resolution? I think from my thinking, my ears, et cetera, usually it's about -6, -8 to about +6, +8. Somewhere in there, if the fader is sitting in there, I feel like I'm good. I'm going to be able to do my work really, really good here. This is not to say that the fader needs to go up and sit at 0. Even though there are times when you might want a fader to do that, maybe it's a VCA control where you want to have the highest amount of remote control for that fader. But the crux of the argument here is I want to have a gain structure that allows my input faders, specifically my input faders, to be in a high resolution area of movement. Okay. All right. So with that in mind, that's how faders work. Now, it's important to remember now, and we'll talk about this about the third slide in here. Faders are an attenuator, right? They're an attenuator. They are a way to turn things down, not necessarily add gain to the path, even though there's enough buffer in there that you can kind of do that plus dB, 10 dB. It's not there to add gain. It is an attenuator, right? Now, here's the thing. There are also knobs on your console, of course. And guess what? Bus knobs are really also faders, right? They're just in knob form, not fader form. And the Paragon console always did a really good job of demonstrating this. So did the Gamble. And Gamble was always really good about doing this as well. And if you notice the markings on a bus knob, like an aux bus, they're set up exactly the same as a fader. So the same things apply here, right? Where we want to get those auxiliary knobs up in their high resolution portion of their throw, right? Where we can make the finest adjustment. And, when we're in the same room together, I always ask this question about this because it's true. Everybody, I think, has experienced this at one point or another in their career when they're setting up, especially guys that are mixing front of house and monitors. You see this all the time where, maybe the artist is on stage and you're kind of mixing monitors for them and they kind of get your attention. And they go, I need my voice up just a little bit, just this much. And you reach up and touch the aux knob and they go, no, down, 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 right? And it's like you barely touched it. You probably, most likely in that situation, have the auxiliary down in its low portion of the throw where small changes are creating big changes in decibels to their ears. So especially in ear mixes, you would want to really have this optimized where both the fader and the auxiliaries are operating in their high resolution portion of their throw. Is that making sense to everybody there? Yeah. So, that when I talk about optimizing a console for use, it's not just optimizing the gain pass through, it's optimizing the operational aspects of it as well, right? Where you can do the finest detail work. That is part of gain structure, is getting the console in that position. Combination of operational finesse and audio optimization. If you can optimize both those things, then you're really, really, as they say, swimming in tall cotton. So let's go on. Now, another place where we have knobs, obviously, is in the preamp gain. But here it's a little different scenario. Even though it's the same thing, this is a situation, this is a circuit path that actually adds gain to a signal, right? So it is an amplifier at this point. So check it out. It actually kind of works in reverse here to a fader, which is an attenuator. Here we have something that's adding gain. And notice the resolution difference here. The resolution at the bottom of the throw is actually very high. So we can make very small changes in gain and do this delicately until we get up into the very, very top end of the throw. Then we're making some considerable gain changes, small distance there, right? So it's important, it's important to remember that it's the opposite for preamp gain. Preamp gain versus an attenuator, right? Is that making sense? All righty, let's carry on. All right, so let's, as I've done in the past, let's just ask the question here. Obviously, if you want to answer it, you can. But I would do this in person normally. I would say, okay, let's just start with the basics here. Why do we need a preamp, right? And, with really young people that are just coming into this for the first time, I shouldn't even say young, just people that are young to the experience, they come into it. There's always this moment of, well, wait a minute, I've got a gain knob and a fader, why do I need two of those things, right? And it really, once you inherently understand this, you're really on your way to understanding it, right? So forget that we need, for now, for the purposes of this, forget that there are different sounding preamps, right? That some preamps sound different than the others, some sound better, some sound worse. Forget all that for this discussion. The discussion here is, why do we need one in the first place? And the pre, in and of itself, needs to get a mic level signal to line level signal. That's its only job. It's its only job. So if we have a signal coming in at mic level, we need to get that signal to line level. Seems pretty simple, right? So it kind of begs the question sometimes. I wonder why there's so much confusion about this, And maybe if you understand it at that basic level, all of a sudden this gets a little bit easier. So then, of course, the next question becomes, well, if it needs to get it to line level, where's line level? I mean, I'm looking at a preamp there. I got my mic level signal coming in. How much gain do I add to get it to line level? And why is that important, right? Well, as you'll see here, the importance of it is that whether it's a digital console or it's an analog console, the design, the inherent underlying design of the console is designed to work at line level, not at mic level. All the circuit path, everything is optimized at line level. That's where it's going to carry the best specs. It's going to, all the gain stages, as you'll see here, are set up to work at line level. So we've got to get that signal to line level. So back to the original question, well, where's line level? Well, we have this thing called a meter, right? That is going to tell us exactly where line level is. And that's our path in. That's how we start to optimize audio in terms of gain structure here, right? So somewhere on that meter, regardless of how it is labeled, somewhere on there is a representation of line level, right? So if we turn up the gain until we get it to line level, then we're good to go from that point forward, right? We've got that signal kind of optimized at its input stage and carrying forward there, right? So it sounds simple. It sounds simple. And honestly, it is simple once you kind of understand some rules and get some things in your head here. But what becomes a very important piece of doing this, which hopefully is evident to you right now, is how important the meter is. The meter is crucial to doing this. All right, so let's kind of dig in here and understand metering, because this is wildly all over the shop. in live sound. And, you know, if I was to take a poll right now and ask every one of you, do you know what kind of metering you have on your console in terms of ballistics and in terms of the values that are being shown? Describe it to me. I wonder how many could do it, you know? So what you're going to see here, you know, I've got an analog input meter shown here. I've got this thing called Venue DBR, which was a meter scale that we basically invented to help you out in Venue, the original Venue console, to get you from analog to digital. And then there's, of course, the Pro Tools scale, which is a digital recorder that uses dBFS, dB full scale, right? So it's dBu, dBr for reference, and dBFS. But all three of these are showing you exactly the same thing, just in different ways, right? So for instance, whoops, as you can see here, if we run up a signal to 0 dB in analog, that's going to present a +4 output at its signal path, right? Well, if we run a signal up to 0 dBr, same thing. It's going to output +4 at the next, going into the next stage. Same thing on Pro Tools. If we put a signal up to -20 dBFS, in Pro Tools, -20 dBFS is line level, which would present +4 at the output of that device or the output of that stage to the next device, right? It's all the same. It's just, you're just looking at it in different ways, all right? Now, with digital, of course, there's another aspect to it. And I'll just be as transparent as I can about it right here. This is a little controversial. Since I originally did this presentation, I've actually checked with a number of A to D designers, converter designers, some golden ear engineers, etc. And there's differing takes on the validity of this. I believe it, and I swear I can hear it. I'm betting other people can hear it as well. I know the golden ears claim they can hear it without question, but the A to D converters designers are not so convinced, but play along here. All right, the math works out like this, where, you know, in an analog circuit, if we have low signal level, a signal level that is down below line level, then we're not really meeting the specs of that circuit for the signal, meaning there's going to be competing noise, there's going to be possibly competing harmonic, well, actually not harmonic distortion at that point, but other types of distortion and clarity in that preamp. I think everybody here who's been on an analog console would tell you almost unequivocally, there's a sweet spot for every preamp. That's somewhere around line level, I guarantee you, right? If you want to, as we've talked about in previous labs here, if you want to start to get harmonic content into that preamp, that's certainly above line level. That's when you start to get nonlinear in the preamp. So let's compare that to digital. What happens in digital? We know there's, you know, no harmonic information in a digital path, et cetera. But the thing to remember is there's a preamp on the other side of that converter, right? It's an analog preamp. So, you know, in the digital, the math kind of works out like this. For a 24-bit converter, it works out like this. It's about 6 dB per bit of math being used, right? So what that speaks to is that the higher you can record in terms of level, the higher the resolution of the recording, right? It uses up all the bit math the closer we get to dBFS, 0 dBFS. Now, stop yourself right there from thinking, okay, well, I got to get all my signals crammed into the top of this scale here. You do not, okay? And I'm going to hopefully get that across to you here. What you want to get is a good signal at line level. It's important to get at least to line level here because that'll give you 21-bit resolution in your audio there, which is more than fine enough for what we're doing and also safe enough to keep you away from having overs, right? Remember, in digital, no clipping. There's only overs, right? Where we run out of math, where we literally, believe it or not, it may not sound like it, but it's muting. The audio is actually muting because it's running out of math component there. All right, so yeah, as somebody said, it's running out of ones and zeros. That's exactly right. So, you know, we want to keep the signal at a safe level, yet we want to have it optimized for line level, which is around -20 dBFS. Now, for those of you out there, if you're in the audience here or you know people that are like this, I know engineers of note that are on record as saying this. In digital, it doesn't matter. That level doesn't matter. Just put it anywhere you want. And, you know, I bristle when I hear it because it's like, okay, well, that tells me that you don't believe in the bit math. Okay, peace. But the unmistakable realization is there's a preamp on the other side of that converter. And those two things are correlated. If I've got a really low A to D conversion, that means I've got a really low preamp level. It's nowhere near firing at its optimized zone, right? So, you know, that's the thing. And like I said, it's the A to D part of it, you know, we can debate that all day long. But the preamp side of the A to D converter is definitely not optimized if you're running at a low DBFS level in a console, right? Maybe a show of hands here. Are you guys buying off on that concept? Are you in the camp that doesn't believe there makes a difference there? I see AJ Essington has posted the word wrong, so I'm going to call you out here. Can you jump in there and give us your idea of what's wrong there?
No, I was agreeing with you, Robert.
So when I see you say wrong,
I said I said wrong. No, wrong meaning level is important when it comes.
Okay, there we go. Go. Okay,
yeah,
Ben. You and I right now, we're just right here, buddy. Thank you. I appreciate that. Okay. Yeah. So, you know, my point of it is all of this matters, right? And really, you know, that's the crux of, look, guys, that's the crux of all these labs that we're going to talk about in the past and going forward is that details matter. In audio, details matter. They all matter. The minute you catch yourself saying, that probably doesn't matter, get ready to have your ass bit at some point by it, right? It's going to happen. So in audio, it's all about the detail work, right? And the more, you know, I've said this a million times in mix clinics, et cetera. Mixing and doing audio is a million small moves. It's not a bunch of big moves, not a big move with a plug-in or anything like that. It's a million small moves. And the more of these millions of small moves that you master, the better audio you're going to have at the end. There's just no ifs, ands, or buts about it. Okay? So we're going to stick on metering here for a while because this is so important to get this done right. And I don't care what console you're on, this is important, right? Whether it's analog or digital, this is important. All right, so let's take a look here. And, you know, there's a lot of debate out there about where is line level in a DBFS meter. And I would tell you, it's not across the board. I don't want to say it's across the board. But in our world, in our live sound world especially, the vast majority of consoles are at -20 is line level to +4. All right, so, and this is right out of the Yamaha manual. And I probably had more debate about Yamaha than anything, funny enough, right? Which is, everybody's like, oh, I think it's +16. No, it's like, you know, -18, -20. All over the shop. It's like, well, fellas, this is right in the manual here. Okay, so take a look here. So the break point between -20 and -18 in that meter is -20. All right, and that's right where line level is in your Yamaha product. And if you go right to the top of that scale, which would be +20, and add the 4 dB on the output, that's +24, right? Which is that signal drive level, right? That's not a sensitivity, that's an output level at that point. So without question, in Yamaha, it's -20 is line level. Okay? I hope we settle that. I feel like I need to carry this slide around with me on my phone. So if everybody, the debate ever comes up, it's like, well, here you go. Just check out what they say in the manual. Okay. All right, so let's go here. We'll see if PowerPoint holds on here. It was a little sketchy through this section this morning. Maybe that had something to do with the web. So the thing to remember here, let me move this real quick, get it out of my sight. And the thing you must realize is there's lots of different meter scales depending on the way you're metering, right? So I've just pulled up, I've gone to a Pro Tools session here and pulled up, looks like seven examples here of metering that, you know, we will look at here in terms of their scale, and we're also going to look at it in terms of their ballistics, because you have to have this information if you're going to assess this well. So take a look at here. We got a VU scale. In digital, we got an actual VU scale. We'll look at where that goes. It goes -20 to 0 to +3. Just like what? A deflection meter, a deflection VU. That's exactly right, Tim. So, you know, this would scale exactly the same way. Even though we're seeing it in a digital form, it's going to look and act exactly like a ballistic, I mean, a regular VU meter, right? All right, let's go to our next one. Well, digital VU, that's going to be a DBFS scale, right? So -60 up to 0, a max point of 0. So that's clearly a digital scale, digital DBFS scale. Same thing for an RMS meter. Same thing for a venue. Well, actually, a venue RMS meter is that DBR scale. Remember, venue console is a digital console, yet look, it's an analog scale on the meter here, right? It goes -60 to 0, 0 to +20. So the underlying thing that you would grab from that is, okay, -20 from the top of the scale is line level there. Right? How about sample peak meter? Okay, same thing. It's a DBFS meter. It's just looking at sample peaks. Venue peak, again, it's the same scale as the DBR, even though we're going to, as you're going to see here, it's a different metering ballistic. And of course, PPM digital, which again is a sample meter. It's not even really looking at waveform. It's looking at sample peak there. But it's digital, obviously, so it's going to be in a DBFS meter as well. Okay? So my point of bringing all this up is once you have these all there, well, check this out. Let's see if I can get it to work here. Come on. This is a steady state signal. This is a tone going into those channels. They are all reading the exact same tone, but they look different, right? They look different. So, you know, if I don't have an expectation of what I'm looking at here, I'm going to make bad decisions, right? So take a look across the board here. I'll see if I can kind of annotate this to bring it to your attention. Oops, hang on. I got somebody sitting in the waiting room here. Let's see here. So look, let's see here. How do I want to do this? I'll kind of do it this way. All right, so let's take a look at VU here first. This is the interesting one, of course. And again, this is solid state signal. But look at what we got here. The signal is showing up at about 3 dB below 0, which would be line level. And you got to remember that there's a VU ballistic with this. So that's really just kind of the crest factor of that wave getting knocked off by VU. It would want to act like a deflection meter here. Let's take a look at these others here. So here's a DBFS meter that's at -20 with a 3 dB crest factor in there. -20, 3 dB crest. 0 here, which is -20 under the hood with a 3 dB crest factor. -20, 3 dB crest. 0, which is also -20 DBFS underneath the hood. -20 here with 3 dB crest factor. So these are all telling you the same thing if you're reading them correctly, right? So important to know what you look at. Just, you know, I always use this example. I don't know that it's a great example, but I'm going to use it anyway. If you looked at your VOM meter with your 2 probes plugged into the wall and you read it and it said, well, it looks like it says it's 12 volts. Would that tell you that maybe you're on the wrong scale? I mean, you know there's 120 volts coming out of that wall. Why am I reading it as 12? I'm metering it wrong, right? I'm interpreting that meter incorrectly. The signal is right. The reader is wrong, okay? So let's clear this out of here and we'll go to the next little bit. So that is meter scales that we're talking about there, right? So let's go on to our next, oh, this was the VU discussion. Sorry, I don't want to leave this out. So you got to be careful when you're using a VU meter, right? Especially with things that have a lot of peak information in it. If you're going to be setting levels with VU, because that peak information will really fool you. You want to almost want to kind of eliminate your view of that VU. Wow, say that twice. In terms of its peak information, you want to look for its RMS information and get it in the right spot, because that deflection meter will not be able to handle all that peak information. It's going to pass it. It's too slow to do it. All right. So just be aware if you're in VU. We don't really use actual VU very much anymore, except for in external devices. We don't see it on consoles anymore unless we're in analog. But be aware if you're on a console that's actually using VU of how you're setting your levels there. You can get fooled there very quickly. All right, so here we are going to talk about different metering ballistics. And this is where it really gets interesting here because each one of these VU styles has different ballistic characteristics to it. And you need to understand what they are in order to make an accurate reading of what you're doing. Right, so again, we have the same meters up: VU, digital VU, RMS, venue RMS, sample peak, venue peak, and PPM digital, okay? So same thing, we're gonna run the same signal into all 7 channels and check out the difference here. It'll do it. Go, here we go. Hope this is coming across all right on the web there. So we're metering different ballistics here, right? Now again, these are all telling you exactly the same thing if you have the right expectation of what you're looking at. So how can it be so wildly different? Because some of it is peak information. Some meters are looking at only peak information. Some meters are only looking at RMS information. Some meters may be looking at a combination of the two. Like I said, PPM digital is a great example there where it's looking at sample peak, not even waveform peak there. Remember, VU has all that peak information kind of shaved off of it in terms of its ballistic, right? The thing we looked at just in the previous slide. So it looks very low, even though it's reading really exactly the same information here, right? So, it begs the discussion when if you're going to talk about gain structure and you're going to take it seriously in your console in terms of setup, man, the first thing you've got to know is what kind of meter am I looking at? Because all meters are not created equal, as you see here, and then make the right adjustment from there, right? Now, I think I don't know this for sure because I really haven't dug in to investigate it, but I think probably most digital consoles today have a hybrid of RMS and peak metering. That's really the most powerful thing you can kind of have going on. But you've got to know, and I'm going to show you why you need to know right here. I'm going to give you a really golden example of it here. Okay, so let's switch over here. I'm actually going to go to the next slide here to stop this, and we're going to go here. Stand by for me. I got to do a little screen house cleaning here. Oops. Get you out of there. Get you out of there. Okay. So I'm going to use venue here. If you guys have worked on venue in the past, these will be common concepts for you here. But in the venue console, we have the ability to look at the metering as being a peak meter or a VU or RMS meter, excuse me. You have those two choices. And you have to know which one of those you're in if you're going to make a good decision on gain. Okay, because you can get fooled very, very quickly here. And I'll fully admit it, in the early days, the very early days of venue, the default setting on the console was peak. And it used to just drive people around the bend because they didn't realize what was going on. And I'll explain that further as we go on here. So right now you can see I got 2 channels sitting there in front of you, a kick and a snare. And I just personally think drums in particular, percussion, things with a lot of transient response in them, those are the hardest things to really set gain for in any console, let alone digital or analog. But we're going to do that today. I'm just going to do it today. So for now, I'm going to, kind of give you the opportunity to set the gain here. Remember, if you buy into what I've talked about, we want to get the signal level sitting at around 0, around line level, right? That's what we consider optimized. So we're looking at a meter here. Let's just let's take that second one. I guess you guys can see my cursor there. We're going to work on this guy right here. We'll just work on the snare drum. All right. I don't think I can zoom in any more on that. Actually, let me do this. Let's try this. There we go. All right, so you can kind of see that snare drum now, and where the cursor is, you see the color break in the meter, and that's listed as 0 dB, which is actually what what, fellas? Minus 20 dBFS, right? That's our line level signal. And as you can see right now, the snare drum, oops, sorry, let me get the right channel up here. There we go. The snare drum is actually low right now, right? Everybody, I think, would agree that the snare drum input is low in terms of its gain. All right, so I'm gonna play, because we can't really interact here totally. I do this in class all the time, but I'm just gonna start adjusting gain. And normally I would say, okay, somebody in the class tell me when to stop if you think there's enough gain on the snare drum right now. Okay, so I'm gonna start adding it here. Here and do it. And normally people would tell me to stop right about there. Right? I look good? So, you know, in terms of what I've told you, you would look at that and go, well, yeah, it looks like the snare drum's hitting right around 0. That should be good, right? And it's not. It's not near enough level, because you're looking at a peak meter right now, not an RMS meter, right? And something like a drum has a lot of peak information in it, right? So that's what you're looking at drive that meter right now. And I'm going to prove it to you by going here. So I'm in peak metering right now. I'm going to change it over to RMS, and you'll see the difference, right? So now I'm in RMS metering. Look at the RMS level of that snare drum now. Still way low, way low. So there's nothing wrong with having it in peak, nothing wrong with having it in RMS, as long as you know which they're in and set accordingly, right? So even if this was still in peak, I mean, I could still go set the level on this in peak, but it wouldn't be there. It would be, let's see here, see if I got enough gain here. I can't get enough gain on it because I'm in playback here. I've kind of cheated the system here a little bit. Let me do this. Hang on, I'll do it here. I'm going to cheat a little here, fellas. Just bear with me. Get it over here. Okay, so if I was in peak metering, this would be totally okay, right? Because I want to get the peak information really very far up into the dBFS scale without creating overs, if I can do it, so that I can get the RMS portion of that drum, which is very far away from the peak information, closer to line level, right? Okay, so again, now if we go back to look at RMS against that, now look at the RMS level. And I got a little hot there. Look at the RMS level. Now the RMS level is great for that drum, right? Now, you know, I mean, we give you a really, really credible, really easy way to do this in venue land. And it's this thing called gain guess. I'll put on the Avid hat for just a second to show you this, because we worked very hard on this, and the most recent version of this feature is fantastic because it also addresses auxiliaries, etc. If you change gain like this using gain guess, it's going to automatically adjust your auxes as well, which was a problem in the past. So, you know, obviously I got the gain set very low right now. And depending on which meter style I'm in is going to depend on how, or dictate how gain guess works, right? So we use gain guess on venue just by simply pressing down on the preamp gain knob until it flashes. Or you can go to the software, there's a little question mark near the preamp that allows you to do that as well. You can just press on the question mark and it will gain until it flashes, and it will set the gain properly. So what it does is in RMS mode, it will set the RMS level of that signal to 0 dB or minus 20 dBFS. If you are in peak metering, it will set the peak level to minus 20 dBFS or 0. All right, so again, you want to know which mode you're in before you start setting gain. So I'm going to put it in RMS right now and just engage gain guess. Let's see if we'll do it in return path here. So you can see it's just automatically changed the gain for that to optimize it at 0 dB, right? Minus 20 dBFS. So you can, I mean, it sounds convenient to say it, but when I'm setting gain, I do this religiously. It's what I use to set my gain on every input that I use. Because I know it's right. I know it's going to be right. Now, it's not to say, it's not a hard number. It's not that you can't adjust it again. You can certainly go adjust it and tweak it as needed, but you can always gain guess it at any point and get it really in the pocket there, okay? Any questions up to that point? So what I tell people religiously is that, like, dude, the minute you step up on a venue console, that page should be the first place you go to find out what your metering is in. Is it RMS or is it peak? Because it's going to impact how good things are going to go from the first input you listen to, right? So just use this as an example, right? Let's use that drum as an example. If I was in peak ballistics here, and we set that meter like we did, like I would have the class do me right at the beginning, right? Well, the RMS portion of that drum is now sitting down at about minus 15 below 0, right? It's actually sitting at about minus 30, minus 35. What's going to be the response out of the PA with that? What's going to be your response when you hear it? Your first response is going to be, wow, it's not very much gain here. Not very much output in this console. When in fact, it's the input that is run too low here. And you will all start to notice, as we're going to talk about here, that your record levels are very low as well, right? So job first, job one in gain structure is know what kind of meter you're looking at and be able to assess it appropriately, right? Okay, peace. Michael Fraley, can you multi-select gain guess? No, you cannot. You cannot, and that is for good reason, because remember, if you're gain guessing, the actual signal has to be there. If not, it's going to take whatever signal is there and bring it up to minus 20 dBFS. So let's use the crazy example. Maybe I decided I was going to gain guess my snare and my toms all at the same time. Push down those preamp controls. Well, on the toms now, there's nobody playing toms, only the snare drum. I've taken the background noise and moved it to minus 20 dB. The first tom he hits is going to cause a nuclear explosion. So be careful there. All right, so you want to gain guess one at a time. Just do it during your line check as you're going along. Like I said, you can do it anytime. You can regain guess at any point and have it be all right. Maybe the roadie is out there checking the drums and you're gain guessing. As soon as the drummer sits down, he's playing harder, just regain guess it, and you're right back where you want to be. Okay, no big deal. Now, the cool thing, actually, I see Norm. I think Norm is going to address my next thing here. The cool thing about doing this, certainly in venue, and I think this is true of most consoles today, that they will offer something similar to this, is if you can see it here, it's going to be tough to see because it's so small on screen. Once you switch over to RMS, where is my cursor? Doggone it. Get over there. There we go. Why are you not there? There we go. If you notice on the meter here, you'll have to look really close to see this. If you guys are on small computers, you might not be able to see this. But once you switch over to RMS, you'll see the RMS as the full meter, and then you'll see a disconnected LED up here that is the peak information, right? So you're seeing both peak and the RMS, and you can kind of slide that accordingly to get that peak information to fit under the over. Does that make sense? And the signal in the RMS scale, right? I mean, we really don't want to be creating overs there if we can do it. You know, remember, digital consoles do not distort. They just mute, you know. There's no such thing as good sounding digital distortion unless you're Trent Reznor and you mean to do that. You know, I mean, you've done it with intent. Okay. Oh, here's a great question, which we're going to talk about toward the end of this thing. Does the input channel metering point play an important role in gain structure? It certainly can. It certainly can. Maybe I'll share with you the horror story of this that I experienced at one point. Yeah, so you want to be able to gain to meter at the appropriate places as you're adding or subtracting gain to your circuit. Obviously, in this situation, we are setting input gain, so we want to see the gain at the earliest stage of the signal path, right? So here's the horror story of that. And there are times when you want to meter post-insert. I'm going to give you an example of it today. But I was on a situation where I walked in on a console that was already set up and went to work. I won't mention the artist here, he was having a lot of trouble with engineers and stuff, and they asked me to come in and kind of bail water off the ship. So I walk in and I'm looking at all, this is on an XL4, by the way, and all the meters look pretty good, but I'm listening to it just going, what in the world is going on here? Sonically, I was just like, what is happening here? Only to realize after a long period sitting at the console, the light bulb came on, that there is input metering, and then there's post-insert metering option on the XL4. And we were looking at post-insert metering. I didn't realize it had been switched. We were looking at post-insert metering. So, and it's post-EQ as well. So what had happened was, given that they were looking in post-insert metering, they would make EQ cuts, high-pass filters, all kinds of stuff, and then turn the gain back up to get the meter up. You see what the problem's going to be? As soon as I flip that console back into input metering, 70% of the meters on the console were just hanging in the red, just totally in the red. Because they had added all this gain post-insert, post-EQ. Yeah, ouch is right, let me tell you. But, you know, then all of a sudden, like I said, the big light bulb was on. It was like, okay, let's start at input gain here and get everything back in line. And sure enough, once we did that, then it started to sound right again. But, you know, for the inexperienced, uninformed, you know, you'd walk in and look at that console and think, well, nothing looks like it's distorting. Maybe it's the PA, right? I mean, you know, that's where you would go with it, right? So, you know, again, kind of gain structure, it's really so much of the whole game here. All right. Okay, let's see where we go from here. Yeah, let's go back. Unless anybody wants me to dig in there. Let's see. I'm not sure if you answered the question. Oh, the trim option. Yeah, this is probably a good place as any to talk about the trim option. All right, so I won't be able to speak comprehensively about all digital consoles here. I can really speak totally about Venue. I understand its gain structure here totally. And maybe I'll ask you guys a couple of questions here. Maybe I should check the Yamaha manual for this one. But in the Venue world, the only time the trim gets separated, the digital trim gets separated from the pre is when you are in playback. When you are in Pro Tools playback. And if you've seen the virtual sound check discussions, et cetera, you understand the reason behind doing that. We do not give you independent control of a trim there. And there's good reason for doing that. That said, you know, I know Yamaha does. Is that right? Yamaha gives you independent control of the trim? Anybody give me a firm on that? Yes.
Yeah, okay. It does. Absolutely.
Yeah. So my question, is that Winston that gave that answer?
Yeah.
Winston, do you know if that's digital trim or is that analog trim?
It's digital trim, actually. You have both an analog gain and you have a digital gain or digital trim. Right. It's in a different window. It's actually over in the EQ window.
Right. So I'm guessing in that situation, well, I'm knowing in that situation, I'm guessing that would give you a way to add more preamp gain and then trim it back digitally. Is that right?
Yeah, the Yamaha rep is the one who actually showed me that little trick to kind of optimize the sonic qualities of their preamps and stuff. Yeah. And that was the intent, actually, at that point in time. Well, two things. One was to optimize your A to D conversion by allowing to run your preamp as hot as you can without distorting it. But then that may be too hot a signal to run your where you put your fader at, you know, meaning that it's too far down, like you were mentioning earlier, down around -50 or -30.
Yeah, but here's the problem I have with that, right? I I remember you and I talking about this actually not long ago, and I remember going away thinking, well, wait a minute, that mentality is not right there, because that is digital trim, right? And the preamp and the converter are correlated. So if you're running up your preamp, I mean, you could, like, if you tried to run up the preamp on this snare drum that we're looking at right here to get some more harmonic content out of it, you would be creating overs in the converter, regardless of where the digital trim is sitting.
You could. That's why you need to watch what's going on in your meter.
Right.
You can control the ballistics on the Yamaha meters as well.
Yeah.
And so you want to look real closely at what you're doing there on your input with your preamp and your converter. And then the digital trim was really more of an intent to basically be able to get your then faders in the position where you prefer to mix them, like you were mentioning, you know, say -5 to +5 or -6 to +6. So you can get that fine resolution in your fader moves.
Right, which we're going to talk about here coming up here, some ways to do that. Because I totally get it. If that's the mentality behind putting it in there, I get it. I think there's much better ways to do that, especially with regard to mixing music. So I'll throw that caveat in there. But yeah, I guess the point I wanted to get across to everybody to make sure and not miss this now is that trim is not affecting the A to D conversion. That is after digital conversion. That is not pre-digital conversion, right? So it's not really a way to optimize, you know, A to D conversion. You can't optimize the bit depth there. You'll be able to get some more trim, but it's still at risk of overs there, no different than it would be without the trim, right? Everybody, peace there? Everybody follow what I'm saying there? Okay, yes, Gear is saying, problem with the dig trim on channel is that then the level affects the onward signal processing. You are so correct, sir. I am gonna validate that sentiment here in just a few minutes. All right, so let's get back to, let's go back to here now. So as if all of this wasn't difficult enough, we have this additional problem now of plugins, right, of digital plugins, and some of them are emulations of analog, which present its own challenges here in terms of how we handle gain throughout the system, right? So I've tried to just come up with some examples, some of the glaring examples of this to try to help you through this, right? So in terms of gain. So what we're looking at here is one of our old stalwarts in live sound, right? This is a DPR 402. The top one is an actual one. The bottom one is the plug-in version, right? Totally viable, but look at the different metering that they have available on each device, right? This should be your clue to what's going on here. And this one's pretty straightforward. So on the actual device, you have something that has, you know, a 0 dB point, right? And then another plus 18 above it. So it really does, you know, even the 402 didn't really match the plus 24 capability of your input. Once you put it on there, you know, you had the chance to actually subtract some headroom from that particular insert because it was not matching up with the later analog consoles in terms of total gain. However, if we look at the digital version of it, right, look at that metering scale, and that's your first clue at where line level is on the plugin, right? -20 is going to be where the line level is. It's going to match those two things up there, okay? So just treat it accordingly. Don't be looking for that top scale in the plug-in version. It's not going to be there. Okay, you're in digital at that point. Everything's been digitized. All right, let's see here. So here's an interesting one. This is where it really gets interesting, is if we have a plug-in emulation of an analog device that uses a VU meter. Well, now we got all kinds of challenges here, right? Because a VU is going to go from -20 to 0 to +3. Where that digital device really is working in dBFS there. So is 0 dB on the deflection meter actually -20 dBFS? It's a question I haven't really gotten good answers from yet from anybody that talks about this kind of stuff. But I've through some measurement and some other stuff, I've been able to get a sense of it, which I'm going to show you here. And even on the digital, if that is indeed -20, if 0 is -20 dBFS, well, what's +3? Well, you know, it's just like, well, wait a minute, the numbers don't really add up here, right? And then of course you had the added challenge in 1176 land of looking at +4 or +8 dB M as a reference point, right? So, you know, one of them is a broadcast standard, the other is just a standard audio standard there. Scott, go ahead, man. I see your hand up.
Well, we can get to this anytime, but one, there's two parts to this question. So one, correct me if I'm wrong, but doesn't the Avid normalize at peak, like when you start it up?
I think like if you start at a fresh show file now, I believe it starts in RMS now. We changed it a couple years after we released the console. It should come up RMS default now.
Okay, so I've seen two types of engineers. I don't know what you are because I haven't like watched you mix, but a bulk of the people that I've watched mix over the course of the years, Tech Inform and everything, at least from front of house, I've seen some of them. One predominantly was he'll set his actual faders across each channel like at -5, his master fader at 0, and then from there he'll set his gains on each channel to, you know, get the proper gain structure as far as like the meter.
Yeah.
Seen the other side where you'll leave all the faders down, you'll set your gain at the top to where you're reading properly, then you'll pull your faders up. But one of the things I noticed differently when you do that, now you don't have as much play on your faders because you've tapped out your gain at the top, which, okay, great, you've got a lot, but now your faders don't go as high and you can't get a nominal level. So, I mean, can you explain the two differences and why you do that? Because I now do myself, unless this is wrong, I do the faders like at -5, main fader or master fader at 0, and then I set my gains according to that. Right? That's what I try to mix, and then I started EQing to add that additional level.
Yeah, we're going to go through that in great detail here in just a second. So just hang in there. It's right after this section, so just hang tight.
Thank you.
Yeah. All right, so I decided to kind of put together this thing to kind of show the challenge here. Now this is we'll see if PowerPoint plays along here. This has crashed my computer a couple of times here for some reason, but this is an actual 1176 that I have here at the studio. And this is a plug-in version, the Bomb Factory plug-in running on the console. And these two units, as you can kind of see here, this is not meant to be faked. They have exactly the same settings, right? Same ratio, same attack, same release, same input and output level. And they're both receiving the same signal, all right? But keep in mind, one is a digital unit, one is an analog unit, right? So that VU meter up at the top, that's a real VU meter. That VU meter at the bottom is a VU meter representation of a DBFS scale, right? So let's take a look at the difference of these two things. Get it to run here. There we go. Hopefully that's reading. So as you can see that, you know, and I've exaggerated this just slightly, but you can see that that VU meter is peaking at 0, peaking at line level, while the digital one is peaking at line level as well. -20 on the VU scale there, right? So if you didn't know that this was working like this, if you just pulled up that digital emulation of that 1176 and tried to do this, all of a sudden it'd be like, well, wait a minute, man, why is my gain so off going into this unit, right? It's not looking the same, but you have to realize it's a DBFS unit, right? And it's not metering. So it clearly, in this situation, in the Bomb Factory thing, at least from what I'm gathering here, -20 on the VU scale is line level, which would also mean that 0 on that VU is top of the scale DBFS. What that means for the 3 dB above it, I have no idea. Right? You seeing the challenge there? All right. So I don't have all the answers for you there, unfortunately, but my point is be careful. Make sure you know what you're looking at in terms of gain traveling through your signal flow, especially when you start to get into plug-in emulation, et cetera. That can get tricky, really, really tricky in terms of metering and optimizing the unit. Because don't fall into the trap of thinking there's not an optimized level for a plug-in as well because it's all digital. There is, I guarantee you there is, especially with those ones that are emulating the drive characteristics of an analog device, all of those sorts of things. So it all plays there. All right. All right, Scott, here we go. We're going to do this for you now. This is really the crux of all of this, right? And again, please remember, we're coming at this from the context of mixing music, right? You might get away with all kinds of stuff. You're just mixing corporate and playbacks, things like this. But in terms of mixing music, where you have lots of different inputs, lots of different things that you've got to add and blend together, this can get tricky. All right, so we're going to create a very, very simple signal flow here today. We just got our mic signal coming into the preamp. We're going to go to a meter. Then we're going to go to that. We're going to take that input signal and we're going to set it to line level, RMS, right? That's ultimately what we want. We want the RMS level at line level. We're going to take it to a fader that's sitting at 0. We're going to take it to a master output, which is also sitting at 0, and then just take that right to the PA system, all right? Now, for the purposes of this discussion, we are going to make the assumption, we're going to make the claim that everything past the output of the console, the gain structure is okay. It's set up and optimized the way it wants to be. All right, we're going to keep it out of bounds right now in terms of this gain structure assessment. Okay, everybody, peace. Okay, nothing past the output of the console. We're only going to deal with the stages of the console here. So let's take the example. This is the example I always use, and it's a valid one because this is, it's just true. This is how it works out. So let's say for the example that we're going to talk about here, we're going to take a bass drum into the channel here. And you do what Uncle Robert says. You say, okay, I got my RMS level set at line level here. It should be great. Now my fader sitting at 0. It's a really high resolution position. Fantastic. Going to the output. But as soon as I turn it on, it is excruciatingly loud in the PA, especially for the style of music we're mixing today, whatever that is. You just think, well, wait a minute, man. There's no way I'm going to have the bass drum that loud. I'm not going to have any drum that loud for that matter. So you're at your first point of decision here. Where do I turn it down? Right? This is the challenge right now that's going to be able to answer whether you can keep your gain structure optimized here. How do I turn it down? Right? Well, I could turn it down at the fader, but let's just say in this instance, and not that this is this is dreamland or anything, maybe for this particular place in this presentation, I've got to have that bass drum fader down at -20, right? Daryl, you said amps. I'm just going to remind you, everything past the output of the console is out of bounds right now. We're going to assume that it's optimized, so hang in there. All right, so turn down the input fader. Is that what we want to do? Well, the penalty there is really one of resolution, of fader resolution, right? Now I'm going to be very coarse in my adjustments in building that drum set, right? That drum kit. Now remember, I'm only doing the bass drum here right now, but this is going to apply to all the drum channels, right? Well, okay, if we don't want to turn it down there, well, do we go to the master and turn it down? All right, PA system? Definitely don't want to do it there. Now anything I've got to have louder than the bass drum has already been penalized 20 dB. You follow me? And I'll even throw that out for Daryl. He asked if we do it at the amps. Again, the output stage is off limits right now. But even then, if you turn down the amps to where the bass drum felt right in the PA system, you're going to be penalizing all the other inputs by that amount of level, right? So stay away from that just for now. We'll discuss that if we have time here at the end. All right, so obviously the input fader is not the best place to turn it down. The master fader is certainly not the best place to turn it down. Where do we turn it down? Do we go to the attenuator and turn it down? Do we go to and I shouldn't say the attenuator. Do I go to the preamp gain and turn it down? Because this is, I'll just tell you now, this is where most people land in terms of doing it. I turn it down at the preamp gain to get it to be at the right level in the PA system. Well, if we do that, there's all kinds of penalties that come from it. And you're definitely going to de-optimize the gain structure if you do this. So the first place you're going to notice it is, remember, we don't have the bit depth that we want in that conversion. If we're going to turn it down 20 dB at the preamp to get it to be the right listening level in the PA, now we don't have the preamp optimized or the conversion optimized. Hence, our record level is going to be too low as well. Okay? Here's the other piece of it, though. As soon as I turn it down at the preamp, now I'm going to have to adjust threshold on gates and compressors by that same amount. And if I've got to have that bass drum down 20 dB here to get it to be the right listening level in the PA, I may not even be able to get a gate to work properly on there. I may not have enough threshold control to get it to actually work, right? So again, it drives home this point of consoles and all of their pathways are designed to work at line level. That's what you want to do, all right? So we still have the challenge here, though. How do we turn it down? How do we turn it down? And, oh, I'm sorry, I have one other one as well. So in addition, if we, and again, this is the complex workflow that we all deal with. If we're mixing front of house and monitors from the same console, if we turn that down at the input gain, now we've got 20 dB of, we're starting 20 dB down on the bass drum in any monitor mix that we want to send it to, right? Because it comes off of that preamp level. It's a pre-fade level, right? Whether it's post or EQ or any of that, don't worry about that right now. We're just talking about a pre-fade level that's going to get to that circuit pad. So now we've turned that down 20 dB as well. We can't even get the monitor drive to be what it want it to be, right? Okay, so yeah, there's doing it at the preamp, which is what we've done in the past. There's a lot of penalty involved there if you do it in extremes, right? So all of these different areas here suffer if we do volume management through the PA at the preamp, right? That's the lesson really to be learned here for the most part, okay? All right, so back to the question, where do we turn it down? And you know, for you Yamaha guys, you know, I think this is probably why the Yamaha guys, I'm guessing, did it this way, where you could say, okay, well, I'm just going to go to that bass drum and turn it down 20 dB on the trim. But I still question it as I think about it, because have you now stolen 20 dB of gain from any of these other paths, from the gate path, the compressor path, the aux bus path? I got to believe you have. I guess I'm going to have to go find out. I have to go look into that. Okay, so where do we turn it down? This is my take on it. This is what I've been promoting. This is what I've learned since I was 19 years old and have used it forever in analog and digital. So here's the answer. It's an audio submaster. Now remember, we're in mixing live music here, all right? Live music. So with this concept of audio submaster, what we're going to create is a master volume for a given family of inputs, right? And by family, I mean, okay, this is the drum mix, right? This is the guitar mix, and we're going to create master volumes for this. Now, I'll fully concede to everybody here that this has now gotten really complex with all of these bus-to-bus workflows. Because I see a lot of guys doing this now. I mean, they've really bought into it, this idea of, well, I'm going to take my kick in and my kick out, and I'm going to send that to its own subgroup so that I have one fader for both of those. That's fine. If you want to do that, I got no problem with you doing that. But at some point down the line, you still have the issue of, do I use that to create just an offset for the bass drum? Or am I going to create a drum mix offset to get it to be the right volume? Because at some point, you're going to take both those mics, sum them down to a group, and then I'm hoping you would take that group and send it to a drum submaster as a master volume control for your drums, right? That would, I think if I was doing it, that's certainly the way I would do that. Now, in that situation, gosh, it's going to get complicated here. Maybe I better stick to the prezo here first, and then we'll come back to this. Because once you start incorporating VCAs on top of that, you can actually manage that without an audio submaster. But I'm going to stick to my guns and say, I don't really think that's the optimized way to do it for mixing music. So to back up a little bit, we're going to create a submaster for each family of instruments, right? So in this case, we've done it for drums. In this case, we've done it, where all the drums, and usually if you're creating a drum submaster, it's going to be all the drums plus drum effects processing, all parallel processing is housed underneath that one audio subgroup. So you literally have a master volume for your drums, right? So that way you can set all your input levels, optimize them all, leave all your inputs up in high res, do your balances to create your drum mix, and then have a master volume for that you're going to turn down to get the listening level right in the PA system. Okay? That's the idea behind it. So leave bus to bus out of it for just a minute. We can certainly talk about that. I'm happy to chew on that for as long as you want to chew on it, because it does, it does do some cool things, but it also creates some challenges as well. So let's go the other direction now, and let's go back here just for a second and take another situation here. So what if I have, let's go the other direction. Now we've got something that's too loud now. What if I've got a vocal coming in here, right? The vocal comes in and I've optimized the gain for it. But now the vocal is not loud enough at all in the PA for what I'm going to do, right? It's not loud enough for the show. What is that telling us? As live sound engineers, what is that telling us? Remember, everything past the console, we're making the claim that it is optimized and good to go. So if I can't get that vocal up loud enough right here, right now with my gain, my input gain optimized, my fader at 0, my master at fader, what is that telling me? Christopher Dean, you are 100% correct. That is telling me I don't have enough PA system. Right? And there's nothing, guys, there's nothing you're going to magically do here in terms of gain, plugins, whatever, to get enough gain to make that work in that room without enough PA. All right. So I kind of want to dispel that myth here. There's nothing you're going to magically do here. Can I squeak another 2-3 dB of gain out of a gain stage or something? You know, turn up a compressor a little bit, blah, blah, blah. Yeah, of course you can. But that's far from optimized, and it's probably not going to be enough for the day. But my point of bringing it up in total is there are days when you're going to have to say, okay, I got to mix with the vocal at that level and try to make it a clean, distortion-free show and just make it at a lower volume, right? There are going to be days when you have to do that, especially if you're out doing these one-offs night on night, different console, et cetera. You're going to run into it sooner or later. We don't run into it as much today as we used to, I can tell you that. But that's kind of the opposite problem then. The question would be, where do I turn it up? And my point is, there is no place to turn it up. Not in keep your console optimized, right? You need more PA system there. If I was going to go try to get it anywhere, and it's fraught with danger, I would do it outside the console. I would try to get more gain to drive the PA. But still, your gain is gain, folks. You're limited to as much as it exists in the system to begin with, okay? All right. So let's carry on here, this discussion. I knew this was going to be a lengthy one, and I'm going to need to get through this. But I want to leave time to discuss this because I know there's lots of questions. So the next piece of this is, if I don't use an audio submaster, why can't I use a VCA here? And there's nothing inherently wrong with using a VCA here, but I just, just in terms of my belief of what is right and what is wrong for the optimization of the console, to me, VCAs are the wrong thing to use here to create listening level, right? To create that listening level through the PA. Can I group all of those drums to a VCA and turn them up and down? Of course you can, but there's penalty that comes with that, all right? Especially if you're using bus-driven compression, and even if you're using effects, reverbs, et cetera, all kinds of things. Because remember this, a VCA is a remote control for the original faders that it's assigned to, right? There's no audio passing through that VCA. It's strictly a remote control. So as I turn that fader down, guess what comes down? Any post-fader levels that I have driven out of the console, right? If I've got that fader level going up into auxes, I've got it, especially if I've got it going through an aux to a compressor, well, now that fader is in control essentially of the threshold of my compression. And if, I'll say peace, if you implicitly want to do that, where the harder I push the fader up, the more it drives into the compression, peace. Absolutely. If that's the way you want to do that, that's okay. But if you want that, that spanked parallel compression thing to sit and rest at a specific threshold, this is the wrong one for you, Every time you move that fader, you will have taken it in or out of threshold, okay? Same sort of thing kind of applies for the reverbs, where, if I steal that 20 dB of gain away from the post-fader drive, now I'm trying to drive a reverb and I can't get enough gain to it. That might even hold true if you're using an external reverb where you go digital to analog out of the console, analog to digital into your digital processor. Now you've got that bit rate and an input gain problem for the external processor as well now, right? So again, using an audio subgroup kind of eliminates all of this. You can keep your mix very, very stable and, build it the way you want it to sound and then just have a master volume for it. And luckily in today's world in, digital consoles, we're bus rich. I mean, we have tons and tons of bus capability to be able to do this. I mean, certainly that's what's driven all the bus-to-bus workflows and all this other stuff that's coming, right? So, I see some of you guys have been kind of asking in the chat here, et cetera. If you want to voice a question here or you got some concerns about this, let's bring it up now before I move into this last little segment here. Let me see where I'm at here. Yeah. Okay. Let's stop here just for a second and take some questions. Is this making sense to you guys? Scott, is that answering your query there?
Yeah, of course. So Audio Submaster, since you and I have been dealing with the Avid so much and everything, can you put it in context as to what that would be on there? Because now at these churches and stuff, I'm back on my Midases. So now I'm taking a lot of the stuff that we've used on the Avid and I'm trying to do what I came in to have to fix on these Midases. Like, I literally froze the first day I looked at the Midas again because I couldn't remember. So
I broke you, didn't I? I broke you. I'm sorry, man.
With the Avid, how am I going to take this over to the other desks? Like, what do you mean?
Well, I don't know if you'll be able to, is the honest answer, unless they offer Audio Submaster style busing. And really, a lot of the consoles that do this, I think Yamaha did this for a while, and they may still be doing it this way, where an aux bus can be used as a mix bus. And that mix bus can be assigned to the left, right, or whatever you're going to do there, right? So in that situation, you would take one of their auxiliaries and turn it into a mix bus, and that would be an Audio Submaster, right?
Which Midas are you using, Scott?
Say that again?
Which Midas are you using?
Pro 2 front house.
Yeah, you absolutely can make subgroups with that, no problem, all day.
Yeah, but this may be like a stupid question, but audio subgroup, like, what are you talking about? Like, I'm thinking VCAs, DCAs, that kind of thing, but what are you talking about as audio subgroup?
Audio subgroup means the audio is going to be assigned to that group, and the audio is actually going to pass through that group.
Oh, you're just talking like an actual group.
Yeah.
Okay, using your groups. Okay.
Yeah, an audio group, Audio Submaster, same thing there.
Okay.
But here's the difference I'll give you, and I started intently using that term differently because I wanted people to be thinking of it as a submaster, meaning it is a group of inputs that is also going to the master, but I have control over it now as a group, right? Whereas sometimes if we think of just grouping those things together, well, that doesn't necessarily imply it's actually going to the submaster. Might be, going to the left-right master, maybe going somewhere else. Whereas if you take that group of drums that's in a single fader and assign that fader to the master fader, now you have a submaster volume for the drums, right? Pre-master, submaster. You follow me there? You basically have two masters. You have one for the drums and then a master for all of the groups.
That makes sense. So then would you do for your VCAs, would you do like what you talked about where you just have your kick on one, or like kick in, kick out on one VCA, or you do a drum VCA, guitar VCA, keys VCA, and then just do groups for like a group for your kicks, a group for your snares?
It's a longer discussion, which we will not have time for today, but I would encourage you to go back and look at the lab on grouping and VCAs, because I cover all of that in there. All right.
Okay.
Now, obviously, that has changed a little bit with all this bus-to-bus workflow that is going on now. To me, the thing that would make the most sense there, just in terms of operation now, the thing that would make the most sense right there would be to assign a VCA to both that kick in and that kick out, and have a high resolution control for it, regardless of where those kick in and out faders are sitting. The thing that is challenging with that for people is they now have a fader that has no metering, because VCA is not going to have a metering, and they can't EQ it as a composite. You follow me there? There's no EQ on a VCA. There's no level meter on a VCA. That's just a remote control for those two things. You would have to spill that VCA to get to the kick in, get to the kick out, make an EQ change, etc. Whereas if you use a bus-to-bus workflow and have it be a group, now you have two kicks going into a group. That group also has metering. It also has equalization on it. It also has compression on it. You can do that as well, and then assign that to your drum submaster or directly to the left-right, whichever you choose there, right? So you can do that. As you guys have known in the past, my concern with doing that is latency. Is anybody handling the additional latency there by doing that? Or are we just throwing caution to the wind and doing it? So, I would encourage you, if you're thinking about doing bus-to-bus there, and again, in the context of music here, right, where frequency addition and impulse matter, Be careful there. Be careful. You can set yourself some real traps there if you're not careful. Okay.
Good part is you answered the other question, because I always wondered, and I don't think you tapped on this the other day, but as to why people use groups on top of VCAs, I was like, why are you grouping things so many times? Other than using like parallel compression and that kind of stuff.
And I can answer it in one sentence, because one of those group scenarios is volume setting. It's volume, loudness in the PA. I'm setting a volume for that family of instruments in the PA. And the other grouping, meaning VCA, is control. It might give me control of inputs within that subgroup. Like I might just have a VCA that's just kick, snare, and overhead, right? But that's happening inside that group that has set the volume for the drums in the PA system.
Gotcha.
Right? Yeah. I mean, Scott, I really encourage you to go watch that lab on grouping and VCAs. I think it will answer all of those questions for you right there.
Will do.
Really strong one, yeah. All right. Well, we're at hour 20 already. This is going to be a long one today. We'll just keep going here. I hope you guys are okay with this. We'll get to this next piece and I threw this in intentionally because this is something that we've been able to do this kind of thing forever, but this has somehow gotten really complicated with digital consoles, this concept of using external preamps for your systems. But it's actually really cool in digital. It's amazingly simple to do. And again, I'm going to speak for Venue here. I can't speak for the capabilities of doing this in all digital consoles, but I can certainly speak to the signal path in Venue that you can do this kind of thing. All right. So actually, let me get a couple things on here. I'm going to need to show you. Let's turn this on. Let's see here. I think I'm going to need this one on as well. All right. There he is. Okay. All right. So let's talk about using external preamps. Maybe we want to use something that we think sounds much better than our onboard pre's, whatever we want to use, okay? So really, you use these exactly the same way, whether you're in analog or digital, right? The idea is that this external pre wants to bypass the internal pre. It does you absolutely no good whatsoever to take an external pre into the actual mic pre on the console. I mean, it's like taking this great sound and funneling it right down to your onboard pre. You're going to be in exactly the same situation you were without the external pre. And this whole exercise right here is going to require you to be able to visualize a circuit path and understand where we're going to inject this external preamp. But it's the same whether you do it in digital or analog. And you're going to insert it on the insert return point. That is going to bypass the internal pre, right? So that's the idea here. Now, how you do it in digital versus how you do it in analog is a little different, right? So in analog, you're going to have an actual send and return point, a physical send and return point, dedicated physical send and return point, and you're going to return that preamp there. In digital, it's a little different. Depending on how you do it, you can, because it's digital, we can come in the actual mic pre and actually bypass the pre and bring it and just address the insert return point with that XLR. So that's the thing you got to realize. But the thing that trips people up all the time on this, I can't tell you how many times I have said this to someone trying to do this. If you're going to insert that pre on the insert return, you've got to be able to meter post-return. If you just insert it on the insert return and have your metering still in the earliest part of the stage, it's going to look like there's no signal there. Right? You're not going to be able to see it. That pickoff point for the meter is earlier than your preamp. So you must be able to look post-return to see your external pre. Okay, so that's job number one. If you want to see that external pre, especially on your digital console, you better be able to have some post-insert metering options. Okay, because it's going to be important to you to do what? Set your gain structure properly. Right, you got to have access to that meter. Okay? Now, if you're going to, once you do that, the kind of the penalty that comes along with it, I guess I'll call it a penalty, is, well, how do I do additional insert processing then? What if I want to use a compressor or something after the preamp? I've used up the insert point. You have to put it in series with the actual preamp itself, right? You have to patch them together and then bring all of it into the insert return. And, you know, this is still this way on Venue right now, where if we brought in an external pre, I'm pretty sure it is on the latest software anyway, we brought in an external pre into the insert return, well, the onboard EQ and the onboard compressor and the onboard gate is before that return point. So now you don't have access to those on that external pre. Now you could build it in plugin, which is what we always suggest people to do when they're going to use an external pre, and all of those things will come after the preamp, or you just add additional hardware to your situation, right? So I'll give you an example of this here. Actually, I'll give you the real example of this. I'll show you this actually in an example or in action once we get through the little diagrams here. Okay, is that making sense to everybody though, in terms of meter point, et cetera, that you got to be able to do that if you're going to return these things to the insert return. And I'll just tell you something, this whole concept, you know, understanding circuit design to this level, this was the genesis of virtual sound check, was being able to do this, you know, this kind of thing and understand what was happening here. So, all right, so let's go on. So like I was saying, in digital, we actually have some interesting things that we can do here that we can't really do in analog. It's similar to what we can do in analog, but not the same. Remember, in analog, we have dedicated insert, send, and return points. It's usually going to be on a 1/4-inch jack or a patch bay, et cetera. In digital, you can make those send and return points any set of XLRs. At least you can on Venue. I know that, where you can do it on a local set of XLRs, or you can actually use a stage rack to do this. All right, so in this situation, you could bring in the output of your external pre right into an XLR on the back of the console and have that address the insert return on any given processing channel. Right? It could go on any channel that you want to do it, where that XLR addresses that return point. All right. Likewise, which is unlike a digital or an analog console, I could actually bring that external preamp into the mic pre input on the stage rack, and then have that XLR address the return, therefore bypassing that preamp. All right. I'm not coming right into the preamp there. I'm just bringing it into that XLR, and then via the software, I'm saying, see that XLR that's got my external pre in? Bring that into the insert return, please. Don't just bypass the preamp. Okay? So you can do that. Absolutely can do that. All right, so let's talk about some of the caveats that go along with that, though. All right? So if you're using an external pre, let's see where we go here. If you're using the control surface for the injection point, right, you're going to bring it into the control surface. You can still use the stage 64 pre on the same channel that you on the same processing channel, right? So I could actually have both of those preamps available to me if I inject this insert return on the console XLR, not the stage rack XLR, okay? And what's going to happen there is your send point becomes available then, right, to the onboard preamp. So you could still use that stage rack preamp and its send point, believe it or not, even though you're using an external pre, which is pretty cool, right? It's still accessible to you because you haven't patched anything over it. You're using the XLR on the console. And then alternatively, you would want to do this, or you might want to do this, because keep in mind, if we come in with an external pre on that insert return point, we've kind of sacrificed any true virtual sound check there. We can still kind of simulate virtual sound check, but we won't have any type of tracked gain between that external pre and the recording, right? We have to manually manage that at that point. But what you could do, certainly, is wire the same input to the stage rack and to the external pre. And then at that point, you would have the ability to record both a processed version of that, maybe let's say it's a vocal, processed version of the vocal and an unprocessed version of the vocal on separate tracks, right? You could even, if you needed to, you could actually kind of virtual sound check with the pre, the onboard pre, and use the external for the show, right? Now, that, like I said, that's not perfect in terms of managing gain back and forth, sound quality back and forth, especially if you've got a string of processing in that external environment there. That could get a little dicey to handle. But my point of bringing it up is just to get you to understand the circuit design and what's capable there, what's possible there. Okay? So in that situation, you're bringing in the external pre into the back of the console, accessing that XLR, or addressing that XLR to the return point, and then you still have that preamp available to you, that other preamp. You could use it for anything really at that point. If you had some input you just needed to track, but you never needed to use it in virtual sound check, plug it into that stage rack XLR, open up the track, and it's going to record it right there. You won't be able to hear it, but you could certainly do that. Okay. Let's take a look at another scenario here. Right. So if you're using the stage rack input though for the insert, then you lose that preamp, that internal preamp, and you lose its send point. Those have been eaten up now. You don't have the ability to access those. And if, again, if the additional processing is desired on the external pre, you're going to have to put it in the chain. You're going to have to wire it up in series with that external pre and bring it right into the return point. Okay. And then if you're going to record that, external pre, you'll have to do that through a direct output. That'll have to be through a post-insert direct output, most likely. Well, it would actually, or post-fader if you want to do it that way. But you would have to dedicate a patchable record track to it to be able to record it, right? So there is a little bit of penalty that comes with it in terms of virtual sound check, et cetera. But like I said, you know, I think if I was in that situation and I really wanted to use an external pre to record an artist, but still have my virtual sound check, I think I would go back to the wide situation, you know, where I would Y his microphone to both pre's or split it, however you want to do it. If you want to isolate it, you can certainly do it. And that way I got some realistic virtual sound check listens that are going to happen, especially for a vocal. I might want to do that and then just reserve the goodness for the show, right? Okay. All right, so I got a way to show you a little bit of this stuff here. Let me get to the camera. Let's go here. And I'm going to shrink this down a little. All right, so this is an external pre, and that I've got, and it's a chain. Actually, you can see I got a little summit limiter in conjunction with the preamp there, and I've got it addressing the hardware return here, right? So if you want to see how to actually do this, I'll give you the actuals here. Let's go to the patch bay. All right, so in terms of, if I go to insert return, or inserts here, why don't I see you there? What's going on there? Oops, sorry, my bad. Gotta go here, okay. So I'm bringing this in on the back of the console, and I'm using XLR number 3 as my injection point to the hardware return, okay? So if we go back there, you can see, oops, back over here. Oh, come on, cursor, play with me. So you can see that I have the insert return here coming in on console analog 3. That's where I'm returning that to the console, right? And then if I have the hardware button in, which I do there, as you can see, oops, damn it. Cursor challenge today. Oh, cursor's acting weird. All right. As you can see, I got hardware insert in there. And help me. If I take it out, you can see that the signal should go away. If I can get my cursor to play along here. And actually, yeah, I'm kind of getting ahead of myself here. So I've got a signal also plugged into the onboard pre here. So if I go to hardware return, you can see that this is actually controlling gain here, right? I'm actually turning up gain. That is the preamp working in conjunction with it. I have, gain control on the compressor. All of that is working there on that external pre. Okay. Now, I've also got this signal coming in to XLR8 on the stage rack, right? Actually, let me show you this as well. So we're looking at post-fader metering there, or post-insert metering, excuse me, post-insert metering. Sorry, I got somebody in the waiting room here. Somebody showing up very late. So if I switch to pre-insert metering, notice I see a different preamp there. That is the actual stage rack pre that I have plugged in with the same signal, right? So here's post-insert metering, here's pre-insert metering, and this preamp is actually adjusting that. This is the stage rack pre in that channel being adjusted. And it's not going anywhere right now because we've interrupted that signal with the hardware return, right? But if I wanted to come out of a send point with this preamp, I could certainly do it. If I wanted to record that preamp, I could certainly do that as well. Let me go here. I think it's this guy. Where are you? That would be this guy. Let's see if I can zoom in on this a little bit. All right, so if you look at the first purple channel that I got there, that is being recorded directly from this preamp. You can see those two levels are correlated there, right? So even though I never hear this preamp, I can actually record it, right? Because remember, Pro Tools records directly after A to D conversion, right? So this preamp could be used for anything. Maybe it's a click track, whatever, something I don't need to hear ever during the show, but plug it into that pre and use it, and then use your external pre for the signal that you want to use it. So my point of bringing all that up is really just say, just because you bypass the preamp doesn't mean you still can't use it. There's plenty of use for it if you want to do it, right? So that should really kind of drive that home there, hopefully, okay?
Where are you making the changes for your metering, switching between insert or mic pre, or where are you making that change?
I will show you here, sir. It is, I've set up an event to do it so I can do it on a switch, right? But if you're going to do it globally, you would do it here. Let's see if I can get up here and do it. We go to options, interaction, and then go here. So you can drop down and see top of channel, insert return, or post fader, right? So I've just, like I said, I've just set it up where I can make that global change just with a push button on the console. I've set up an XY switch to be able to do that, right? So you can look at it instantaneously, which I would recommend that you be able to do. You be able to look at those positions quickly. You know, it's important when you're kind of setting gain to make sure you're not making boo-boos there, right? Okay.
Right. Now, those are strictly global options there?
They are, yeah. Currently they are. We haven't done it on a per channel basis yet. We may at some point, but right now it's a global change.
It seems like that would be a nice option if you were doing external hardware type inserts like what you're just talking about.
Especially there, yeah, especially for external hardware inserts, no doubt about it. Yeah. Right. So is that kind of making sense to everybody in terms of preamp? But keep in mind all these gain structure discussions, et cetera, they all apply whether you're using internal pre or external pre. Same thing applies there, right? What's critical there is to be able to meter it properly and get your gain set properly, right? What do you think? Fun stuff? Gain structure, we just don't seem to ever stop talking about it, man. What can I tell you? Oh, well, let's see. I don't think I got anything else for you here. Hopefully that is making sense to everybody. I'll just put up the discussion slide here. Yeah, you're not going to play along. Okay. All right, any other questions? I see a couple of thumbs ups, which is nice. Yeah, it's really fun stuff. And oh, actually, you know what? Matthew has had his hand up here forever, I think. Matthew, come in there, man. Sorry about that. I just zoomed past you. Lay it on me, brother. You got a question?
Yeah, no, don't apologize. I guess maybe this is all assumed, but any of this sort of processing would have to be done. If you're the kind of person who likes to put processing on your output, you can't even touch that until you set up all this gain structure first, correct?
I would totally agree with that. Yeah. Because everything you do input wise is going to impact it. You know, it's almost like that's the icing on the cake. You can't ice the cake until you build the cake, you know.
Sure. And then as opposed, and I don't know if this is a different topic of discussion, but how does that kind of relate to outputs and matrix levels if you're not traveling with a PA and maybe those are changing every day?
Yeah, well, that's the biggest challenge of all of this, right? But I would say to you, I'll give it to you in this context. From my perspective, the reason you want to get this console so well sorted out gain structure wise and get your mix sounding right in terms of gain, structure, everything is because going forward, without question, you're going to need to deliver it to other places besides a PA system. You're going to need to stream it. You're going to need to get it to news organizations. You're going to need to record it, all of these things. So just, treat it just exactly as if you were in the studio where that output stage is fixed, right? And get it sounding right here. And then the only variable that you're going to deal with day to day is what's happening outside the console, right? Especially if you're carrying your own console, then it's like if you show up and all of a sudden the PA is very quiet when you output what you know is good level, then you know the problem has to be at the drive stage of the PA system. Is something turned down? Have you guys had a really hot show come in and you've turned down the input to your processors? Whatever it's going to be, it's going to allow you to treat the console as a constant and then go attack the problem, right? All right. Well, that was a really long session. I had a feeling it always turns into a really long session, man. I mean, when we do these things live, this thing can go on for hours, with people interacting on it. But I hope that addresses a lot of this. As I said to Scott, the other piece of this is how to use that group structure to get your music balanced at the right volume for the PA system. And I would encourage you as a part of this presentation, just go and check out that lab on groups and VCAs, and it will talk about this very thing to you. Because that's the second part of this. Usually I have a live demonstration of actually how to build a mix. And I'll just say this, once you get gain structure really kind of hammered out and working really, really well on your console, so many other things become easy, right? Like even doing festivals becomes easy if you have a good gain structure approach. It just walking up and dialing up something becomes really, really easy to do, especially using groups. I mean, I know Dave Morgan's in this room. I know he's done this. I mean, I've been at festivals where I did not get a line check pre-show. We're just going to do it at set change. And I've got to build a mix from the ground up, including line check here in 30 minutes. And for my money, submasters are the key to doing that, where I just solo up that submaster, build a drum mix to it during line check, and now I have a master volume control for that drum mix when the show starts. When the show starts, if the drums aren't loud enough and the vocal's too loud, it's 2 fader moves and I'm more in the pocket. And then I'll go start working back toward the input side and getting things sorted out. But you do that enough times, you get good at building a mix to a submaster. I mean, you can have a pretty damn good show right out of the gate on a festival with just a line check and and some balancing. Might not even hear it through the PA in those situations, So it takes skill. It takes skill to do it. But if you have all the right pieces in place, you're metering it right, you're doing all of those things right, it comes together pretty quick. Okay. All right, fellas, that was a long one, and I thank you for hanging in there for all of it. We'll pull the ripcord here. We will be 2 weeks until the next lab. I haven't decided what we're going to cover there yet, even though we got a suggestion here today from doing that. I'll have to kind of look back through the list and see what we're going to cover in a couple of weeks, but hopefully you got something out of this, and we'll see you in a couple of weeks. Get to work out there, everybody. Let's go back to work.